Really?
Classification regression tree.
Crap.
Yeah.
Josh said he couldn't remember it. He said maybe I did that one. It was like fine. Then he'll lecture on something equally important, probably. So I decided that we talk about resampling because this is something that you need to know about. And again, my resampling lectures are at a more mathematical level, so you're going to get the abbreviated version of what you need to know or what you should know about something called resampling. This is resampling. And maybe I do want the, I'm going to go back and forth. Suppose you have a very simple challenge, a seemingly simple challenge. You have some data, and some person asks you a simple question like a confidence interval for the median. Every time you report the mean of a variable, you probably make the confidence interval as well. At least you should, because you're an applied statistician. And we always care about the variability as well as the actual value. So, if you will generate some nice random data, and just for fun, we'll make it exponential is particularly annoying. We'll make it a random exponential. And say, okay, and rows. And maybe we'll have 50 values and say, okay. So it turns out that's a random exponential distribution, which, if you drew a histogram of it, you get something that doesn't look very normal, and you could take the log of it, but it won't do anything because it's an exponential distribution. It'll look a little better, but if you're asked for a confidence interval for the mean, you'd go down here and you'd report 0.72, and the confidence interval would be between 0.549 and 0.899, and life would be good. Because you would have reported the mean of the distribution, and that's great. But then you would go, the mean's not a very good measure of the middle of that distribution because it's highly skewed to the right. So you might report the median. In fact, you should report the median. For a skewed distribution, the median is a better measure of the middle than the mean because the mean is getting pulled out. There's 0.72. 0.72 is about in there. and the median's at 0.58, which is way back in there. And so for skewed distributions, typically one reports the median of the distribution. But if you're reporting confidence intervals for things, like you're supposed to, then where's the confidence interval for the median? 0.58 plus or minus what? Well, turns out that's not a very easy question for a statistician.
Sorry.
Was it talking to me? I don't know. Right. So what's the confidence interval supposed to be for the median? So, having learned something from me, you go to Wikipedia and you look up the median and find out that they do know how to make a confidence interval for the median, but it depends on knowing this distribution right here. Mathematically knowing that distribution. This is a smooth version of something called the density, and you have to know that in order to make a confidence interval for the median. But you don't know that. And there's no way that you're going to know that. You can say, oh, I'm going to assume that it's normal. But it's not normal. And so that's a bad assumption. So even for something as simple as the median, we don't know how to make a confidence interval for that, which is really kind of weird. Why can't we do that? Well, it turns out the math says that the variability depends on this distribution. It's not like there's no central limit theorem, there's nothing that saves you. We have no reasonable way to make a confidence interval for the median, which isn't quite true because we have resampling methods that I'll talk about. So the median isn't the only statistic, the sample median isn't the only statistic that we have trouble estimating variability for. There are lots of cases where the theory hasn't been done or the theory doesn't work. So, and it never ceases to amaze me what people can come up with. Someone wants what's the coefficient of variation? That's another one. Sigma divided by mu. And there are lots of things that we can't make confidence intervals for, and there are lots of situations we can't deal with. And as statisticians, people will always come up with more things that we can't deal with. Someone wants to test whether the mean is equal to the standard deviation. Why would they want to do that? I don't know. People come to us with all sorts of crazy stuff. And we don't know how to do that. So resampling is a trick that I think from the early 80s, maybe late 70s, that Brad Efron came up with this original idea, and there are thousands of variations on the theme. But the game is basically to understand the variability of something like this, if we call the sample median m hat, then typically the confidence interval would be m hat plus or minus standard error of m hat. And there'd be some table value that goes in there. But this is what we can't do. We don't know how to do it. Actually, we do know how to do it. We just don't know how to calculate the standard error thing. So resampling is a way to assess the variability of a statistic that we don't know the asymptotic theory for. We don't know anything about. So you would think that resampling would be the answer to all our problems, but it turns out it's not. Do I need this anymore? I don't know. Let's turn this off. So the game is to use the data itself to study the variability of your statistic. So you do the following. So this will be called, this is a bootstrap. And you'll see bootstrap confidence intervals, bootstrap tests, bootstrap everything. And we will also talk about the jackknife, which is a new and not new, an improved version of the bootstrap, according to me. And I've been trying to convince the statistical world of this, but no one listens to me. So almost everything gets bootstrapped. And it goes like this in algorithm.